Students, they are talking about the structure of maltose, and we should know that maltose is the combination of alpha glucose and alpha glucose. So everyone write that maltose is the combination of alpha glucose, and everyone knows it that glucose exists in the pyranose ring form. So let me quickly write the pyranose rings. And we know the slogan of alpha glucose, it's down, down, up, down, and the last carbon top CH2OH and remaining all RH. Let me write the same over here. We have the slogan down, down, up, down, last carbon top CH2OH and remaining all RH. OH and H go out as water. The O what remains here will connect the two. Now they are talking about acetals and ketals. Everyone know that acetals, they formed by aldehyde, and ketals, they formed by ketones. This is what a very basic thing that you must know about. Acetals you will get from aldehyde and ketals you will get from the ketone. Because both are glucose, there is no scope for ketals. The reason I know that glucose is aldose, right? It is aldehydic. So because it is aldehydic, there is a scope for acetals, hemiacetals, but there is a no scope for ketals. So wherever I am finding ketal, I can just I can just rule them out. So A and B got ruled out. Now let's look at what do you mean by acetal. Acetal, it looks like this. O become OR, O become OR. It is a dialkoxy compound. Geminal dialkoxy compound, we call it as acetal. If it is like one OH and another OR, we call it as hemiacetal, right? So if I will see this, we have a CRR, we have OR and OR, we call it as a ketal. If there is one OH is still present, then we call it as hemiketal. I hope everyone got the point here with the clarity. Okay, now let's talk about here. C attached to H, it is attached to OR, it is attached to OR, and another side there is R. So, there is OR here. So I know this is aldehyde, so this is altogether acetal. I can see acetal over here, right? Now come to this way. C attached to OR, it is attached to H, it is attached to R, it is attached to once again what this side, it is attached to R. This is not acetal, it is not ketal, I know that, because it should be OR, OR in order to call it as acetal. It should be OR, OH in order to call it as hemiacetal. It is none of it. Let's look at this. C attached to H, attached to OH, attached to R, attached to O, R. C attached to H, attached to OH, attached to R, attached to OR. So what is it? It is hemiacetal. Acetal, hemi. So hemiacetal. So all of us can find there is a one acetal that is over here, and there is one hemiacetal that you will find over here. And exactly I can see them in the option D. So I must take option D here as right answer.